Hello, class. This is the second recording, and I want to quickly go through what we did last time. Just a review, and then I did some couple of examples. It was left with one, so I will do that. Then there's one more concept left in chapter 2, and I would like to go through. Okay, so let's do this. So after we look at forces and how to resolve them in 2D. And then I believe we went ahead to solve or find the resultant of concurrent forces, okay, in the plane, or coplanar concurrent forces. That's 2D. So we just have to resolve it and then collect all the x, collect all the y, and then extract the magnitude and direction. We did that. If you don't really need to write them in IJ or column form, but if the question is already in column form or IJ, then we just add them and then we extract the magnitude and direction. So then we'll move to 3D, that in space, where the vector is in space. So we define it in like in X, Y, Z space. Okay. The unit vectors in the X, Y, and then the Z are I, J, K, respectively. Now, if I talk about if you are doing 2D, then it's like you have this four planes. Okay, these four planes, like we call them quadrants. Okay, where the positive x meets the positive y, then it's like first quadrant, and then we have second quadrant, third, and so on, which you are aware. But if you are looking at 3D, then we are in space. We are kind of in space, so we normally call it octant. Okay, so you can be, I don't want to say first octant, second octant, that. Normally we don't have anything like that. So because in space, when you are doing 2D, we can easily say the direction is clockwise or counterclockwise to the positive x and so on. But here we don't do that. We define define these angles called coordinate direction angles, which are the angles that the vector, in this case the force, makes with the each of the axes x, y, and then the z. Okay, so we know we define every vector. We define every vector as its magnitude times the unit vector in that direction. And unit vector is also, if you rearrange this, unit vector is also that it's a vector over its magnitude. Okay, so if we define a is axi plus ayj plus azk, then if you substitute here, then you're going to get a unit vector as like this: ax over ay over that. And then, strictly speaking, if you come to the diagram very well, you're going to see that cosine alpha is also linked to ax over the magnitude a, in that order. So the unit vector can also be given as this. The unit vector can also be given as this. Then, so in class, what I said is the magnitude of every unit vector is 1. Okay, so if you want to find the magnitude of this unit vector written here, then it's square root of cos square alpha plus cos square beta plus cos square gamma. And then if you square both sides, then you're going to have the unit vector square equal to cos square alpha plus cos square beta plus cos square gamma. But then this would be like 1 square, which is 1. So we came out to this. Let me clean the screen. We came out this expression. So what this expression means is that, for example, if you know 2 of the angles, you can easily use to find the other one. But then I make the caution that the vector can make an obtuse or an acute angle to each of the axes. So this alpha, beta, gamma can be either obtuse or acute. So we did example 8 in class, very easy, where you are given two forces, F1 and F2 in IJ form. It can be 2D, can be 3D. In this case, one of them is more 3D, the other one is 2D, but we don't matter. We want to find the magnitude of the resultant and then the three angles, alpha, beta, gamma, coordinate direction angles. So you just add them, get magnitude, and then use cosine alpha equal to that, cosine beta equal to that, and then cosine gamma equal to that. Then you just find it. We also worked this example in class. That's the last example that we did, where you're given a force with a magnitude of 20 newtons, and we know the angles it makes with each of the axes, but one of them is missing alpha, and we're trying to express F here in terms of something I, in terms of something J, in terms of something K. Okay, but obviously we don't know alpha. If you know alpha, then F here is a certain Fs I, a certain Fy J, a certain Fz K, and Fs, as you know, is F cosine alpha. Fy is F cosine beta, and Fz is F cosine what? Gamma, and so on and so forth. Where this F here is the same as the magnitude of the force, and it's 20 newtons. Okay, so all that I need to do is we use that formula, cosine square, that's for the A part, alpha plus cosine square beta plus cosine square gamma equal to 1. And we need to work out what is alpha. Okay, I remember I did square root and I say it's plus or minus, and you have to. Okay, I think I have a little challenge. Okay, I think I have a little challenge with my internet, but I think it's back. Let's hope the video doesn't break. Okay, so I was saying the vector is in the positive side of x, positive side of y, and positive side of z. So this alpha is acute. That is between 0 and 90. So I remember in class, I took the square root, and I have I think is it cosine alpha equal to plus or minus 1/2. So we took the cosine alpha equal to half, and then I have alpha to be 60 degrees. Then you just put it in this formula, okay? Or you can also look at it as F vector is magnitude of F times the unit vector, okay? Where the unit vector is given by this. See, then there's substitute, and that's what we did. Okay, so the main thing I want to do here is work the next example, which is example 10. So I'm going to switch to OneNote. Okay, so I'm going to switch to some white screen to write, and that is the example, I believe that is example 10. Yes. Okay. So in example 10, you are given two forces, F1 and F2 in space. F1, as you can see, the magnitude is given, and its alpha, beta, gamma is given. So it means we can write it in IJ. Okay, no problem. What about F2? Okay, once again, I think the internet went off. So let me continue. So I was going to work this example. Okay, so we write each of the forces, including the resultant, as IJK. Okay, so let me see. Okay, so let's start with F1. So F1 vector is, I want to go with magnitude, which is the magnitude, times the unit vector, okay? Times the unit vector in the direction of that. So let's do that. So the unit vector is cosine alpha. Alpha is the angle it makes with the x, so the angle is 45 degrees. Add cosine beta. Cosine beta is the angle that the force make with the y, which is 60 degrees. Of course, I need to put my I didn't put. I need to put my j, I didn't put. Okay, cool. And then the angle it makes with the z, so which is cosine 120 degrees, and that is k. And I'll close it. And this is in newtons. You can leave it this way, or you can also convert to decimal, or you can write it in exact form. Let me write it in kind of the exact form. Okay, let me write it in the exact form because it's easy to do that. You can also write in decimal. So I'm going to go for exact. Cos 45 is root 2 over 2, and 2 goes here. 150, isn't it? Yes, 150 root 2. Then I add cosine 60 is half. So half that'll be 150. Nice number to do with. Cosine 120 is negative half. So this is negative half. Let's see. And that is negative 150. And that is K in newtons. So good. We've able to express our the first for this F1 in IJK form. So we'll do the same thing to our R, which is the resultant. Note, we used to use FR for resultant, but it doesn't matter whatever you're given as a result. It's just a symbols, okay? There's a symbols. So whatever is given, we use that. So R, and look at the question very well. It says R acts alongside the positive. So R is pointing the positive direction. So R is lying here. Let me use a different color. R is lying here, like this. So that's your R, and you have to write it. So this is very easy. Magnitude is that, and the unit vector in the y positive y direction is what j. So this will become 1,000, and then j, and then you close it, and it's in newtons. You're done. Okay, and that is your R. That is your R. So now R, which is the resultant as a vector, is your F1. Add your F2. What it means is that implies your F2 is equal to your R minus your F1. Easy. So you just subtract. So let's substitute. So our F2, this is F2. Our F2 here is equal to our R, which is 1,000 J, minus our F1, which is 150 root 2 I plus 150 J minus 150 K. And then we subtract. Let's see. This is going to be F2 is going to be negative, because this is only the I, negative 150 square root of 2I. And then this is 1,000 minus that. 1,000 minus 150 is what? That is 850, isn't it? 850, or did I do something wrong? 850. And then again, you have to be very careful here. This is negative, negative, so that is plus. So plus 150K. Let me put everything square bracket and then newtons. Okay, cool. So that is F2. Let me put a notice. That is F2. So this is F2. It's enough. Unless maybe they want you to find the magnitude and direction. So let's go back to the question. Let's see what they want. Okay, cool. The question says specify the magnitude. The question is specify the magnitude. So there's the magnitude. You don't want anything else. So we go ahead. We don't want any angle, anything. We go ahead and find the magnitude. And the magnitude is square root of 150. Some of you like to put a negative, so let me put that square root 150 all square. 150 root 2 all square plus 850 all square plus 150 square. And then you use a calculator. Let me give me a minute to do that. So square root bracket 150 root 2 all square. I believe I've done it well. 850 all square, add, and then 150 all square. I hope there's no any mistake in what I've done. Okay, this is coming out to be, if there's some error, let me know in class, and I will check. 88.81 something 8194 something. Okay, and so on. Newtons. And that's what they ask. Okay, they didn't ask us for angles, anything. That is the way I put the question. Oh, this question is in the textbook, but in the textbook, the magnitude of the resultant was 800. Here I wrote 1,000. So please just take note. I wrote 1,000. That's the difference. The textbook, I think, also want the coordinate angles, alpha, beta, gamma. But I have shown how to find alpha, beta, gamma. So I didn't ask you. I just wanted the magnitude. Okay. So that ends that concept. Now, so I'll end this first video here, and I'll do another video to finish the chapter 2. To finish the chapter 2. Okay. Thank you. Bye.